So hello guys, what's up? We are back again with another question from our DSA series. And this is our next question. 2035 partition subarray into two arrays to minimize some difference. So guys, let us see what is this problem all about and how we can approach this problem. So guys, in this problem, just a second. So guys, in this problem, we are given a array and we need to partition it in such a way that the sum of two equal halves, we need the length will be 2 into n, and we need to partition it into two equal halves such that the sum of the difference of the sum of these two halves is minimized. Okay, for example, in this case the array was 3973 and we partitioned it into these two halves, 3 and 9, 7 and 3. And now 3 and 9 sums up to 12, 7 and 3 sums up to 10, and their difference is 2, which is minimum in this case. We could have partitioned it like 3, 7 and 9, 3. Yes. So then the difference would have been 3793. Again, the same, which is also 9733. In that case, the difference would have been more. So we have to find out what is the minimum absolute difference we will provided we will distribute the array elements into two separate half elements. Now we can use the meet in the middle approach. One question we have already discussed. You can go and check it out. On such approach, we can use again the meet in the middle approach. What the meet in the middle approach says that in order we can generate the subsequences of half the sum of subsequences of half the array and other half of the array separately and can treat them individually. So what our approach be like? Let us see. Just a second. Yes. Yes. So what we are going to do, we are going to take, okay, so what we need, take second. Yes. We need to partition array into two halves. We need to partition our array into two halves. Let's say P1 and this is P2. Okay. So we need to partition the array into two halves. Now, and I know that the sum of these two halves, will be the total sum, let us say, which is T. So P1 plus P2, no matter how I partition, P1 plus P2 will be T. P1 plus P2 will be T. So I can say that P1 will be T minus P2. P1 will be T minus P2. So I will try to play only with P1. I will try to play only with P1 and find out how I can find. Now just think about, if I need the minimum difference, between these two. So can I say that the best case would be P1 is equals to P2? The best case would be P1 is equals to P2. Hence, I will try to have such an arrangement where P1 is equals to P2 or P1 minus P2 equals to 0. Now we will get into that, how we are going to do that in a bit. So first of all, we will use the meet in the middle approach and divide the array into two halves and generate all the sum of subsequences with one element taken, two element taken, no element taken, and n elements taken, where n is n by 2, Okay, so I will try to have such a configuration. Just a second, I will show you this in the code. What am I talking about? Yes. Yes. So I will find all the subsets. Left subsets where find all subset sum, size by 2. Size is the nums dot size, and all the right side subsets. Now you can consider it as a 2D array. You can consider this as a 2D array of something like this sort. For example, if the example we taken, if it is a two size array, so either the elements we are taking for the sum are 0 or 1 or 2. So how many elements, how many one-sized elements have such and such sum? 0 size, that will be 0. And if we are taking all the elements, that will only be a 1 value. So we are generating a 2D array. We will have two 2D arrays. Yes, we will have two 2D arrays like this, left subsets and right subsets, in which we will know that, okay, we are taking this much elements and this is the sum, that much one element, and all the one elements, what is the sum of left side when we are taking all the one elements. So this way we will proceed. Now once we have this, what is the next thing? Next thing is to Yes. Next thing is to iterate these vectors and generate P1. See, I need P1. P1 is for sure of size n. P1 is for sure of size n. So if I am taking 0 elements from the left side, I will know that I have to take n elements from the right side. Yes, I will know that I have to take n elements from the right side. Because I am generating P1, I am interested in generating P1. If I am taking 2 elements from the left side, then I will take n minus 2 elements from the right side, where n is small n, which is n by 2, which is the this nums dot size by 2. Okay, so since I know that P1 is of what size? N size. So now let us see, once I have this, once we understood this, how we can proceed. Now we have the subset sums of the left side and right side generated. Now, what we just saw, that we want that P1 minus P2 should be as near to possible to 0. So I want that for that to happen, P1 should be as near to total sum by 2. Agreed or not? Because I need to separate it into equal number of elements. So P1 should be equal to total sum by 2, since P1 plus P2 is equals to total sum, and we are saying that P1 minus P2 equals to 0. So this is a very simple equation which comes to our mind. Now what we will do? Now we will start iterating our left array. Yes, now we will start iterating our left subarray. We could have iterated any subarray. We will start iterating the next subarray, and then we will, yes, corresponding right subarray. So I is equals to 0 denotes that I am taking no element from my left subsets array. I am taking no element from my left subsets array. Then I have to take n minus all the elements. If I am taking I is equals to 0, all the elements from the right array, all the elements from this right subsets array. So this will be vector of vector. So auto right will be a vector. And now I will sort it so that I can apply the binary search. Very simple. So let us see. Just a second. Yes. So now for int left sum belonging to left subset of I. Now left subset also will be left subset of I will be an array, and I will take each and every element with number of element as I. For example, if I is 0, then there only will be one element which is no element. Okay. For example, I is 1, then I will take all the elements, then I will take all the elements in the left side which are having one element. Okay, so left subset of I will have all the elements which will have, yeah, one element. So I will iterate through that, and yes. And what is needed? What is needed sum from right? Target minus the left sum. And what is the target? Total sum by 2. I want that P1 should have P1 which consists of left sum and right sum should be as near to target. Then hence I will find out the lower bound. I will find out since I sorted this right array. So I will find this needed from some closest value to this in the right array, so that we are very, very close to this. Now, if I find it out, then what will be my, yes, what will be my final sum? Okay, let us understand this. Let us understand this. Now, at this point, I have needed from right. I have this. I have IT, which is as near to needed from right, which is target minus left sum. I have the left sum, that is the element I took from the left array. Now, so IT, I can say that here star of IT indicates the right side contribution, and this is the left side contribution. Okay. Yes. So this is P1. This whole left sum plus star of IT. This is P1, and this is definitely of size n for sure. N here, I am repeating, n here means n by 2, nums dot size by 2. So I have the P1. Now I want the final right array sum, which is P2, will be total sum minus this much, because P1 plus P2 is equals to total sum. Then I will find the minimum difference between the, yes, this is what P1 and P2, and take the absolute minimum. I hope it is little bit clear. Okay, so let us very quickly, let us go through the whole approach once again. Firstly, we divided the total array into two halves, and we got all the subset sums in a form of a 2D array, in which the index indicated the number of elements taken, and the values indicated the sum by taking those number of values. We did it for the left half as well as for the right half. Then we know that in order to have the minimum possible absolute sum, we would want that our P1 and P2 should be equal to, P1 minus P2 should be equal to 0. Hence we took a target as total sum by 2. Now we iterated the left subset array, and we took one element. We also sorted the right array, and then we find out now what is the needed sum from right, which will be target minus left sum. Because I want P1, I am only focused on P1. I want P1 should be equal to target, which is total sum by 2. So what I needed from target right side, target minus left sum, and then I find out the lower bound, which is the closest value which exists in the right side, which is closest to this need from right. And by summing the left sum and the answer I got from the lower bound function, which uses binary search, will be my P1. Now what I did, I just went through, and now I have the P1. Now what will be P2? P2 will be total sum minus P1. Correct? Total sum minus P1, which is left sum plus IT. And now I simply took the minimum difference, and I will return the minimum difference. So yeah, guys, this was all. Thank you so much, guys. Make sure you hit the like button, press the subscribe button, and share it with your friends. Thank you so much, guys. We shall see you next.